Welcome. Today we're going to take a look how we can actually search through an array list to find and remove values. And when we talk about the importance it is to actually go through and remove them properly. And so we have our removal demo right here. It's inside my array list project. And as you can see right here, I have an array list with string using topics, and it's got generate topics inside it. And so I have my bad removal right here. I'm going to call bad removal, pass it topics and blank. And we should have 5, but instead we're getting this. And then we'll have bad removal demo machine learning. And should have 2, but it's this. And then it should be that and go from there. So we'll go ahead and start this up and see what it does. So as you can see right here in the bad removal, it should be 5, but instead it's 3. There should be 2 instead it's 2, and it should be 5 instead it's 4. So let's take a look at the actual removal algorithm and see what happens with that. We have our int remove count is set to 0. My index starts at 0. My index goes through the size, of course, and I have my source dot again index dot equals text remove. I remove it just like I'm supposed to, and I increase my count like this. And so this should work great, but because of the fact when I remove things, if there are duplicate values inside that list, as you can see right here, I have those extra Javas next to each other, or those blanks next to each other. When I remove one, it skips over and doesn't get the next one because the index moves past it on the list. And so we want to make sure when we remove things properly, we go through and do that. And so going forward through the removal means if I want to go forward through removal, I have to make sure I subtract out a value to do that. And so we'll go ahead and take a look at the next step of this right here. And so my OK removal right here. And so I've got my taking blank out, machine learning in Java again, and it should be 5 is 5, should be 2 is 2, should be 5 is 5. We take a look at the actual algorithm for that. And so my OK removal demo, I'm going forward through the list again. Index starts at 0, goes up to dot size, going up by 1 each time. And if I take it out, if it removes it, I remove the value, then I take my index. My index moves backwards down a number because I have to go back because I've adjusted the size of my list at that point, and I have to re-examine the spot I was just looking at. And then my remove count can go up like that as well. And so I have the correct values for that. And so I do this one more time, my better removal algorithm. I'm going to go start with a better removal algorithm and do the same thing, but instead I'm starting off at size minus 1. And I'm going to go to greater than or equal to 0 and go down each one, because when I start at the back and move my way towards the front, my index doesn't have to be adjusted additionally, because as I go through it, I'm correctly adjusting my value as I go through the list, because I'm removing the one I'm at right now. And so anything after that doesn't get affected because I've already checked all those ones after that spot, because I'm going backwards through the list. And so going backwards is the better way to do that. And that's why it's called the better removal demo for that value. But wait, there's more. We also need to make sure we talk about the best removal right here, where we're talking about how we can handle nulls. Because when we're talking about searching through a list, we have to make sure we actually check to make sure we have null, and simply using a dot equals on that with a null value is go, and our app's going to crash, burn, and die, and we don't want that to happen. And so when we're talking about doing the best removal, we have to make sure we do a null check first. And so what I have right here is I have my going through backwards from size minus 1 up to and greater than or equal to 0, going down by 1 each time. And if my text remove is null, or if my source.get index is null. So if either what I'm looking for or the value I'm checking against is null, I then go through and check that value using an equals equals operator, because if I'm searching for null, I have to use the equals equals operator to make that happen, and then dot remove, then have my count go up. Otherwise, I'm going to have my source.get index equals remove, and my source.remove plus passing index, and my remove count will also go up. And because these are two separate things, I have to make sure my remove count happens in separate spots, because they're happening at a different spot inside that logic, making sure that was correctly happening. And my count will be best happen with that. And so as you can see, my 5 and 5 match appropriately as we go through and do that. So again, just as a quick review of that, the bad removal is when I go forward through the list and I don't adjust my index appropriately. So going forward through the list is not the best choice to make. It's actually the worst choice to make. The okay choice to make is to go forward through the list and update your index inside the loop. But that looks really icky. It makes me feel sad inside, because I don't like the idea of modifying the index when I really shouldn't be modifying the index on a for loop. The for loop's logic should handle itself explicitly. Modifying the index means I didn't do my testing right, or I'm doing something wrong in my logic. I think I really like handle it so I can go backwards to my index, because my index's job should only be to process that loop itself. And so that's where the better removal demo comes into play. I start at the end, I work my back to the front and work from there, and I go do that appropriately. The best possible approach, though, is remember, start from the back, work from the front, and then check to make sure if you're handling null potentially, handle that null check first, because you want to make sure you don't cause a null pointer exception when you do dot equals on that, because that would cause your code to crash, burn, and die, and that's sad, and we want to see that happen. So again, when you're working for searching through an array list and to remove values, you want to make sure you start at the end, work your way towards the front, and check for null first, because always do null checks first to make sure you don't crash your code. Hope this is helpful. Cheers, have a great day. We'll see you next time. Bye-bye.